This is section 1.5, video 2. We just have 2 slides to go through here. When you look at what's on the screen, hopefully what you see is familiar. U sub n equals 2 plus 6n, or y equals 2 plus 6x. Really, they're the same, representing the same thing, where what we're learning now is this guy on the left is considered the explicit formula, where the guy on the right is just a linear equation. They really get us to the same spot, but that explicit formula is meant to remind us that we're dealing with a sequence where the equation allows a line to happen. So that's just kind of a little piece of it. So it talks about using the explicit formula to find u sub 22. So that is basically, if we've got the 0th term here, the first, the second, and the third, we don't want to have to recursively do all the work to get to that 22nd term. I don't really feel like doing the recursive formula 22 times to make that happen. But let's remember that 0th term, its value is 2. The first term, if we plug it in, is 8. We had this yesterday or in the earlier video, and you go so on and so forth. You could recursively do this one thing at a time, but what the explicit formula allows us to do is jump right to that 22nd term. So this is saying, I want to know, remember down here, this is your n, here's your u sub n. So you have your term number and the value of your term number. So they're wanting to know what's the value when n equals 22. So every time I see an n, I'm going to replace it with 22. So it looks here that the value of the 22nd term is 134. So to officially write that, you'd say u sub 22 equals 134 is how you would write that the most mathematically correct. What else might we ask you? Why would people tend to like the explicit formula? I think we just talked about that earlier. It is much faster. You don't have to go one step at a time. And to go from the 0th term to the 22nd term recursively, you can make a lot of just simple arithmetic mistakes because you start adding wrong. I do that all the time. Where this, you only have to do really one calculation, so it's faster and less chance for error. Another question that you'll see is to find the value of n so that u sub n equals 86. So this is a little different. This is saying you've got your sequence, and somewhere along the line, the value is 86. I don't know, is that the first term? Is it the second term? Is it the fourth? So we're trying to find, it's like the nth term. So what we're gonna do here, using that explicit formula again, is I know the value of the nth term is 86. So that's u sub n. So I'm gonna replace u sub n with 86, and you solve for n. So you subtract 2 from both sides, divide both sides by 6, and we get n to equal 14. So it looks like that 14th term has a value of 86. All right, very nice. I think I've made this clear, but let's just make sure when we have the explicit formula, we can connect the points. It becomes continuous then. So if you just have a recursive formula, the best you can do is plot the points. But as soon as it turns into an equation or explicit, you can connect them to go from discrete to continuous to make that line. All right, one more example. Retta typically spends $2 a day on lunch. She notices that she has $17 left after today's lunch. She thinks of a sequence to model her daily cash balance. It says to write a recursive formula to model her daily cash balance. It says let u sub 1 equals 17. So if I think about it, that first day, $17, second day, $15, because she spends $2 a day. So then 13, 12, 10, and so on. So that recursive formulas need two parts. The first part was given to you, and then if she's spending or losing $2 each day, it'd be the previous term minus 2, because that common difference is a -2. All right? Then it says to find the explicit formula that represents her daily cash balance and an equation of a line that goes through the points of this sequence. All right, well, let's think about that. An explicit formula, well, the slope we've got, it's right here. It goes down 2 each day. So that slope is -2. Now, what about the y-intercept? The y-intercept, remember, is the 0th term. And I get that that doesn't really make sense in the real world to have a 0th day of lunch, but you need it for graphing, and you just follow the pattern from right to left. We're going up 2 each day. So that y-intercept is 19. That 0th term is 19. So I like to write it as y equals -2x plus 19, that slope-intercept form that I'm used to. That's what feels comfortable for me. The textbook would change it to y equals 19 minus 2x. That would be considered the equation that you're used to. And then to turn it into an explicit equation, the y becomes u sub n, and the x becomes n, and that's explicit. All right, and then the idea of graphing it, again, you have your x-axis and your y-axis. The x serves as your n, the y serves as your u sub n, because you'd have ordered pairs x comma y or n comma u sub n. So the x and the n, the term number matches with the x, and then u sub n, the value of the term, matches with the y. That's it for today. Thanks so much.